Hey everyone, Professor Hank here. So today we're going to take a look at the set container from the C++ standard template library. We'll see some of its characteristics and we'll see how to use it by doing some examples. So let's go ahead and get started. Okay, so the big idea with the set container is that it is going to contain a collection of unique values. So there's a couple of things that you need to know, and that is that all the elements in a set must be unique. So no two elements within the set can have the same value. And the elements in a set are automatically stored in ascending order. So, okay, we're going to be able to define the set container just like we can any other types of containers. We can use initialization lists. We can use iterators. We'll have options for the constructor. We'll be able to have different methods for adding, removing, and searching for values within the container as well. So let's take a look at some examples of sets. So to use a set, we have to include the set header file, and then we're going to use the set keyword, and then we're going to specify in the angle brackets what type of data is going to go into our set. So for this example, we'll just do something simple like integers, but we can use any data type and even our own objects if we need to. And then we're going to name our set container. So I'll just call this nums, and then I will add, or I will initialize my set with these values: 8, 6, 7, 5, 3, 0, 9. Okay, so that's going to initialize our set. Of course, we can also create a set that's empty. So maybe I'll do something like this. We'll say, empty set. And I can also do something like this. I could create a set that looks like maybe this, nums2. And we can have our initialization list here. And maybe we do something like 7, 9, 8, 3, 3, 5, 5. Now remember, the interesting thing about sets, one of the interesting things is that you can only have one copy of the value in the set, right? So this set nums2 will actually have assigned to it 3, 5, 7, 8, 9, even though I have multiple values in that initialization list. Now to see the contents of those sets and to see what we're talking about here, we can use our range-based for loop. So I can do something like this. I can say for auto I, and then we'll iterate over nums. And then we'll just display the contents of that set one by one, right? So what we're going to see for nums is we'll see 0, 3, 5, 6, 7, 8, 9. Because remember, this is an ordered container. So let's check that out. So there you can see there's the 0, 3, 5, 6, 7, 8, and 9. Now let's take a look at our second set, which we created. And that's this guy right here, this third set that we created. And you're going to see that there's no duplicate values in that set. So we'll do for auto I, nums2, and we'll just do a similar thing. We'll just print out the contents. And let's put a new line in between, so something like this. And we're going to see that the second set of values, see how there's no duplicates there? And again, it's ordered. Everything is in order. Now let's take a look at some of the options we have for our constructor. So we've seen what the default constructor looks like, and that's this guy right here, default constructor. Okay, now we can use the copy constructor. So I could do something like set int, and then we'll name this, copy of nums. And I'll put as an argument here for the constructor nums. Now, if I do that, then this is going to create a new set that has all of the values that nums has in it, right? So that'll create a fourth set here. So we can see that that's going to be the same. We could say for auto I, nums2, and then we'll do cout I, little space in between, and then we'll just move the cursor to the next line, and you'll see that we can do that. Okay, so you see there's the 3, 5, 7, 8, 9. So now let's see how we can use iterators and constructors. So first thing I'll do is I will create a iterator that I will initialize with the front of the nums set, and then I will move that iterator one position forward. And then I'll create a second iterator, which I will point to the back of the num set. And then I'll move it one position towards the front. So we'll do something like that. And then I'll create a new set where I'll pass both of these iterators as arguments to its constructor. And then we'll see that we've initialized it with a range of values from iterator to iterator, right? So let's do that. So we'll do set int, and I'll just call this new set. And as arguments, I'll do the front iterator, and then I'll do the back iterator. And then we'll print out the contents of that new set. So auto I, new set, and then we'll see out I, and move the cursor to the next line. So then we're going to see that we're going to get values of a more limited range, right? So then you can see there's 3, 5, 6, 7, 8, right? So where did the 0 and 9 go? Well, in that case, all I did was copy these values from my source set nums into my new set here by specifying the beginning of that range of values and the end of that range of values using the iterators. Now, of course, we can also traverse our set using the iterators. So I'll just do it F, and I'll reset that to the front of our new set dot begin, and then I'll use a while loop to traverse it. So while it F does not equal new set dot end. So cout star it F, and then put a space in between, and then we'll have to update our iterator to advance it one position. We'll move the cursor to the next line, and then let's see what that looks like, right? So then you can see there's the 3, 5, 6, 7, and 8. So, you can traverse the set either way, using that range-based for loop or using the iterators themselves. So now let's take a look at some additional methods here. So let's see how we can search a set for a particular value. So we will need an iterator to do this, and we're going to use the find method for the set. So we'll use as an argument whatever it is that we are looking for. So let's say that we're looking for 5. Okay, now if it's found, then it will return an iterator to the value within the set. If not, it'll return nums.end. Now we can't dereference this. Okay, it's like a null iterator. So if we tried to, we would get an exception, a program would crash. So we're going to need to do a test. So we'll say if our iterator does not equal nums.end, then we're safe to say, what the value is. So the value is star it. Okay. Otherwise, we'll print out a suitable message, maybe value not found or something like this. So let's test that. And you'll see that we're going to see that 5. There it is up there, value equals 5, because that's what's returned by find, the iterator referring to the 5. But let's say that we wanted to search for 1. Well, 1's not going to be in our set, right? So now we're going to see that value not found, right? Because it is the case that the iterator does equal nums.end. Now, if you just wanted to do something like, value found or value not found, you could certainly do that too. Value found, something like this, right? And then we could just leave out that part right there. We don't have to print out what the user asked for or what we put as an argument. We can just do that. Okay, so if we wanted to put a new value in, so let's say we wanted to add 4 to our nums, then we could just do nums insert and then 4, and then we could print it out to see that that has indeed been inserted. So something like this, cout I, and then we'll move the cursor to the next line, and then we'll see that it's going to be 0, 3, 4, 5, 6, 7, 8, 9. So see, there it is at the very top. We can also ask a set how many values it has. So we could do something like cout size of nums is, and then we just do nums.size. And then you're going to see what we should have 1, 2, 3, 4, 5, 6, 7, 8, and 8 values in that set, right? So there's the size of nums is 8. We can certainly empty the set. So we could do something like this. We could say nums.clear, and then you'll see that the size of nums becomes 0. We can remove a specific value. So let's say that I wanted to remove the 7. So I can do something like this. I could say nums dot erase 7, and then you'll see that that's going to be gone when we print it out. So you can see that the 7's no longer there anymore. Now erase will return 1. This returns 1 if successful 0 otherwise. So we could test to make sure that a value was actually erased or not. So, if I wanted to try to erase a value that was not there. So say 2, nums.erase 2. That would return 0, right? So I can put that in an if statement, and I could do something like this. If nums erase 2 equals 1, then I could do cout erasure successful, say. Else cout erasure failed. And so I can test to see if that operation was successful or not. And we're going to see that the erasure failed, right? Because there was no 2 in the set. Finally, let's see that we can store our own objects in a set. So we'll create a class foo, and I'll have it just store a plain old integer for this example. We'll include a constructor, and we'll just initialize I with the parameter. We'll need a accessor for this example. So int get will simply return I, and then we're going to need a way to compare one against the other. All containers require that, so we're going to need to have operator less than be overridden. So const foo, right hand side, and we'll return true if I is less than I. So nothing too complicated here. Turn I less than right hand side dot I. Okay, so that will allow us then to create a set. So we'll do set foo s. I'll use an initialization list here, invoking constructors of 3 different objects. So foo1, foo2, and foo3. And then we'll iterate over it using a for loop. So for auto f of set s, and then we'll do cout f dot get, and then end line. Put them all on separate lines. Let's run that. And you can see there's the 1, the 2, and the 3. We could also do that with iterators as well. Now, if we wanted to search for a particular object within the set, similar to how we did it with integers, so I can do something like set foo, create my iterator, and I'll initialize it with what's returned by find, and I'll look for a foo object that is the same as one of the objects that is in my set. Now, for this to work, this is going to work just fine here because we've got a very simple type of object here. But in order for this to work correctly with other types of objects that are more complicated, you might need to have or to include an equality operator as well. So I'll go ahead and include that just so you know what that looks like. So it's a good idea to do this anyway. So we will return true if both i's are the same. Now, this wouldn't be necessary in this particular example because we're doing a member-wise comparison. But if you were doing anything more complicated than this, then you'd want to make sure that you have, this equality operator in here as well. So that way the find can do its job. Okay, so we'll have our test in here again. If it does not equal s.end, then we will have our little cout statement here. Cout value it get is found, something like that. You'll see that we're going to get that message because, we did find it, right? So what this actually does, this isn't the most efficient thing in the world because this instantiates another object, and it's just comparing to see if both of these objects contain the same value, right? Based off of, the contents of its member variables here. And then if we search for something that wasn't in there, so maybe an object that had 4 in its I, then you're going to see that there's nothing displayed because we didn't find anything. So that's everything that I wanted to show you in this video. What did we talk about? We talked about the set container from the standard template library in C++. We talked about its attributes, and we saw examples of how we can use it with both primitive values as well as our own objects that we create. As usual, if you're a student of mine, you have questions about any of the content in this video or any of the videos in our courses, feel free to stop by my online Zoom office hours or email me via Canvas. Thanks for watching, and we'll see you next time.